Hi, my name is Muhammad Umar Hassan bin Ali Amgolia. Today we are going to learn about the internal components of a central processing unit. So first of all, the central processing unit is like the brain of a computer. It's the part that does most of the thinking, calculating, and decision making to make the computer work. Whether you are playing a game, typing a school assignment, or watching a video, the CPU is handling all the instructions to get the job done. Whether you're doing math calculations like adding, multiplying numbers, helping the keyboard, mouse, and screen work together. The CPU is usually placed in a special slot called a socket on the computer's motherboard, which is like the main circuit board that connects all the parts of a computer. The CPU handles tasks like running apps or games, storing and retrieving information during tasks, and also like we said before, doing maths calculation, helping the keyboard, mouse, screen, and screen work together. And what we have more in the CPU include the ALU, arithmetic logic unit, the control unit, also known as the CU, the registers, cache, and clock. The arithmetic logic unit ALU, it handles the arithmetic tasks like addition, subtraction, multiplication, division, and logical tasks like and or comparisons. It uses additional for all calculations, that is solving, like example, 2 times 3 as 2 plus 2 plus 2 is equal to 6. The control unit, also known as the CU, the control unit manages the CPU by sending signals like clock, hold, and reset to its ports. It ensures that all the components work together to complete different tasks. For example, it synchronizes data movement from cache memory to the arithmetic logic unit. And the next we have the memory unit. It stores data and instructions, and like older CPU use registers. Modern ones also have fast cache memory. The CPU fetches data from ROM or hard disk and stores it in it registers or cache during task. Now we are going to look at the functions of a CPU. The CPU main jobs is to process instructions from programs this through a process called the fetch, decode, execute, story cycle. And we are going to look at each one in details. For example, the first one, fetch. The CPU retrieves an instruction from RAM. This instruction is in the form of binary code. The second one is decode. Once the instruction is fetched, the CPU decodes it to understand what action is required. This step often involves the arithmetic logic unit, which helps interpret and prepare the instruction for execution. And we have the third one, execute. After decoding the computer, the CPU carries out the instruction. This could involve performing a calculation, moving data, or interacting with hardware. And the fourth one is the store. Finally, the result of the executed instruction is stored in memory, making it available for future use or further processing. Now we are going to look how computer hardware components work together. A computer is made up of several key hardware. Yes, a computer uh, have different hardware components that work together. For example, the first one is the central processing unit, the brain, like we can say. The CPU carries out instruction from programs. It fetches, decodes, and executes commands. All the data and instruction must pass through the CPU for processing. The second one is the memory RAM, short-term storage. The, and also we can call it the random access memory. Is it temporarily holds data and instruction that the CPU is currently using. It allows the CPU to access data quickly without needing to go to slow storage devices. And the third one is the storage, long-term storage. It stores programs, files, and the operating system permanently. When you open a file or run a program, it's loaded from storage into RAM for the CPU to use. And the fourth one is the motherboard, the main circuit board. It connects all hardware components. It allows them to communicate with each other through buses, data pathways, and provide power and coordination. Now you can see here in the picture the power supply unit, the power source. The supply unit converts electricity from the wall into a usable form for the computer and distributes power to all components. And we have the input devices, which means sending information in, like devices, keyboards, mouse, and microphones. It lets you send commands or data to the computer. The other one, the seventh one, is the output devices displaying information. Monitors, printers, and speakers show or present the result of what the computer processes. And the eighth one is the graphics processing unit, the GPU, visual processing. The GPU helps to the CPU by handling complex visual tasks such as rendering images, videos, and 3D graphics. It's especially important for gaming, video editing, and design work. And we'll see more how computer hardware components work together. When you perform tasks like opening a web browser, the CPU tells the storage to load the browser into RAM. Also, the CPU uses the RAM to quickly access browser instructions. If graphics are involved, the GPU helps render them. Input from your mouse or keyboard is sent to the CPU. The result is shown on your monitor via an input-out process. All components communicate through the motherboard and are powered by the PSU. Hard disk drive, and now we are going to see the types of storage media and their uses. First of all, we have the hard disk drive. Uh, it is a magnetic storage. We use it for long-term storage of files, programs, and operating system. The second one, we have the solid-state drive. It is a flash memory storage, and its usage is fast storage for system and frequently accessed files. The third one is the USB flash drive or thumb drive. It's a portable flash memory, and its usage is transferring and temporarily storing files. The fourth one is the optical disc, CD, DVD, or Blu-ray. It is an optical storage. Its usage is media distribution, backups, and software installation. And we have cloud storage. It is remote storage over the internet. Its usage is online data access, backup, and sharing. The sixth one, we have the SD cards, the secure digital cards. It is a flash memory storage for mobile devices, cameras, and laptops. And we have the seventh one, the external hard drives. HDD or SSD is an external magnetic or flash storage. It's used for backup and extra storage. And now we are going to see how data is represented on a computer system. A computer cannot understand letters, pictures, or sounds the way humans do. Instead, they represent all data, including text, numbers, images, and audios, using binary, a system based on only digits, 0 and 1. These digits are called bytes, short for binary digits. The binary system, it is a bit is a smallest unit in a computer. 8 bits make up a byte, which is enough to store a single character, like the letter A. Computers use combinations of zeros and ones to represent everything. These combinations are interpreted based on data and type. Now we are going to see a description of how images and sounds are represented in computer systems. Sounds or waves. Computer represents sound by sampling these waves at regular intervals and storing each sample as a binary number. We are going to see some key concepts. For example, the first one is sampling, the process of measuring the sound wave at regular time intervals. Secondly, we have sampling rate, how many times per second the sound is sampled. The CD quality is equal to 44,100 samples per second. The bit depth is how many bits are used to store each sample. Higher bit depth is equal to more accurate sound. For example, we have 6-bit, 24-bit, and the next one is the file formats. Sound can be saved in different formats, and uncompressed and compressed. For example, like on MP3, AAC, we have WAV, and we have more. For example, a sample with a 16-bit depth might look like 01010100101011, a single moment of the sound wave. Images are made up of tiny square called pixels. Each pixel has a color, and computers store the color of each pixel using binary numbers. We are going to look at some key concepts like the resolution, the number of pixels in an image, that is, for example, 1920 multiplied by 1080 more pixels in higher quality. The color depth, the number of bits used to store the color of each pixel. One bit is equal to black and white, 8 bits is equal to 250 colors, 24 bits over 16 million colors common in digital photos. And we have the next one, RGB color model. Most images use a combination of red, green, and blue. Each color channel usually has 8 bits, 1 byte, so red is equal to 8 bits, green is equal to 8 bits, blue is equal to 8 bits, which made a total of 34 bits. We can see an example below. A red pixel might be represented in binary as he read 1, 1, 1, 1, 1, 1, 1, 1, and the green is represented by zeros and blue by zeros. Now we are going to have an explanation of how compression can aid the storage of data, sound, images, and sound. Uh, when we compress uh, uh, files, pictures, it helps us save storage space. Smaller files takes up less room on hard drives, phones, or cloud storage. And also, it helps us to transfer the file faster. Smaller files upload, download, and send faster over the internet. And also, it helps on efficient streaming. Streaming services use compression to deliver audio and video smoothly. And we have different two types of compression, Lucy and lossless. And for the first one, Lucy, it removes extra color details the human eye won't notice. And it is great for photos on websites. File size is smaller, but some quality is lost. For the lossless compressor without losing quality, but it's better for logos, icons, or graphics that need sharp edges. And we can see more here, like you see it makes music files much smaller. Some quality is sacrificed but often not noticeable. And the lossless, it keeps all sound details used for high quality audio and professional use. We are going to see the compression of general data. Files like documents, spreadsheets, or programs can be compressed into formats like .zip or .a uh, or AR. We have compression tools like WinZip, 7-zip, shrink file size for storage or sharing. These usually use useless compression, ensuring the data is lost. And we are going to see a description of the purpose of logic gates. It is building of blocks of digital circuits. Their main purpose is to control the flow of electricity in computer system based on logical decision using binary input values or either 0, which is off, or false, 1, on or true. They perform basic logical operations on one or more binary inputs to produce a single input. Now we are going to see the purpose of different types of computer network. Computer network connect multiple devices, computers, printers, servers, and more. To share resources and information, different types of networks serve different purposes based on their size, scope, and use case. The first one is a local area network design. Its purpose is to connect devices within a small specific area like a home office or a school. Its usage is enables sharing of files, printers, and internet access among nearby computers. For example, an office network connecting all computers and printers in the building. The purpose of different type of network continues. The second one, we have the wide area network, the one. Its purpose is to connect multiple LANs across large geographic areas such as cities or countries. It allows communication and resource sharing over long distances. For example, the Internet is the largest one connecting networks worldwide. The third one is the Metropolitan Area Network, also known as MEN. Its purpose is to cover a large area than a LAN but smaller than a one, typically a city or campus. Each user connects multiple buildings or offices within a city. For example, a university network connecting multiple campuses into a city. The fourth one is the Personal Area Network, also known as PAN. It connects devices within a very small area, usually within a person reach. It enables communication between personal devices like smartphones, tablets, and headphones. For example, we have the Bluetooth connections between a phone and a wireless earbuds. The fifth one is the Virtual Private Network (VPN). It creates a secure connection over a public network like the Internet. Also, it protects data privacy and allows remote access to a private network. For example, employees connecting to their company's network securely from home. And now we are going to see the description of the hardware, software, and transmission media used in computer networks. Uh, Hardware refers to the physical devices that allows to connect that allows computers to connect, communicate, and share resources in a network. Examples of hardware in a computer networks is the router, the switch, the network interface card, the modem, access point, firewall, and Ethernet. The software controls how data is managed, sent, received, and protected over the network. Examples of software in computer networks is a network operating system and the protocols. The transmission media in computer networks of both through which data travels from one device to another. We have wired media like the digital pair cable, coaxial cable, fiber optic cable. We have wireless media like Wi-Fi, Bluetooth, infrared, microwave, and satellite. Uh, Now we are going to identify of a range of World Wide Web technologies. We have the hypertext markup language, cascading style sheet, JavaScript. These are the web development languages. And now we are going to see the web development tools and framework. We have the React, Angular, we have the Bootstrap, WordPress, web browsers like Google, Chrome, Mozilla, Firefox, Safari, Microsoft Edge. Uh, these applications that allow users to access and view web pages on the net. We have web protocols like HTTP or HTTPS. It's used for transferring web pages between web servers and browsers. The HTTPS is secure. We have the FTP file transfer protocol used to upload or download files between computers and web servers. We have the TCP or IP, a foundational set of protocols that govern how data is sent and received over the internet. We have web servers and hosting technology. Uh, we have the Apache software that serves web pages to users upon request. Web hosting services provide space on the server to host websites, like, for example, Bluehost, GoDaddy, AWS, Heroku. And we have web security technologies, SSL, OTLS, secure socket layer or transport layer security encrypts data which is sent over the internet to keep it secure. We have the firewalls, CAPTCHA, HTTPS protect websites and user from attacks and unauthorized access. And we have web APIs and services. We have RESTful APIs. Uh, it allows different system or apps to communicate over the web. That is whether data or maps. Second, we have GraphQL, a modern alternative to REST for managing and retrieving data from a server. We have the JSON or XML data formats used for transferring structured data between web systems. And we have the search and analytic tools, the search engine that is Google, which allow users to find information on the web. And Google Analytics tracks and reports website traffic and user behavior. We have the SEO tools that is used SEMrush help improve website visibility in search results. We have network topology, which is a way that computers and devices are physically connected and logically arranged in a network. It plays a key role in determining how efficiently and reliably data can travel between devices. We have the bus topology. Uh, all devices are connected to a single central cable, which we call a bus. Its purpose is to create a simple, low-cost network for small setups, useful in small LANs where minimal cabling is needed, and it is easy to set up less cabling. And the disadvantage is if the main cable fails, the entire network goes down, performance degrades with more devices. We have the next is restore topology. All devices are connected to a central device, which is called hub or switch. It offers better performance and manageability. It is used in office and home networks, and its advantages is easy to manage. One fail that doesn't affect the rest. But the disadvantages is if the central hub fails, the whole network fails. The next one is a ring topology. Uh, each device is connected to exactly two others forming a ring. It enables data to travel in a circular fashion, often in token parsing systems used in legacy systems like FDDI or token ring network. The advantage is predictable performance, good for high-speed networks. The disadvantage, if there is a break in the ring, it can disable the entire network unless redundancy is built in. We have the mesh topology. Every node is connected to every other node fully connected, or at least multiple paths exist partially connected. It provides high reliability and redundancy, common in mission-critical networks, that is, military IoT systems. Its advantage is highly fault-tolerant, excellent performance, but the disadvantage is it is expensive and complex to implement. The next one is tree topology hierarchical. Uh, it's a combination of store topologies arranged in a hierarchical manner. It creates structured and scalable networks, especially in large organizations. Uh, it is useful in enterprise level LANs. The advantage is it is scalable, easy to manage, but the disadvantage it dependent on root node. If it fails, large parts of the network may be affected. We have the hybrid topology, a mix of two or more topologies, that is store-bus storing, to leverage the advantages of multiple topologies while minimizing weaknesses. It is used in complex enterprise networks where flexibility is needed. The advantage it is flexible and scalable. The disadvantage is it can be complex and expensive to design and maintain. The next one is a point-to-point topology. It is a direct connection between the two devices. Uh, it is to establish a dedicated communication link. It is common in simple or temporary networks like direct file transfers or device-to-device connection. Its advantage is simple, secure, and fast. Its disadvantage is not scalable beyond two devices. And we finish our presentation, and here are the links uh, where we got our informations. And thank you, and thanks for watching. Bye bye.